Download this code from codegive.com, link in the description below. Bytebuffer.tostring, in Java, a deep dive. While the bytebuffer class in Java provides methods for manipulating binary data in a buffer, its toString method doesn't offer a human-readable representation of the buffer's content. Instead, it provides a diagnostic string describing the bytebuffer object itself. Understanding what this toString method actually returns and how to get meaningful information about the underlying data is crucial for debugging and understanding the state of your buffers. What bytebuffer.tostring actually returns. The bytebuffer.tostring method is inherited from the object class and is overridden to provide a description of the bytebuffer's current state. The string generated by bytebuffer.tostring contains the following information. The class name java.nio.bytebuffertype, where bytebuffertype will be either heapbytebuffer, directbytebuffer, mappedbytebuffer, etc. depending on the type of bytebuffer instance. This tells you how the bytebuffer was created and managed. Buffer attributes the buffer's current position, limit, and capacity. POS equals X, the current position, index, in the buffer. This is where the next read or write operation will occur. Lim equals Y, the limit. This is the index of the first element that should not be read or written. In essence, it defines the valid range within the buffer. Cap equals Z, the capacity. This is the maximum number of elements the buffer can hold. It's fixed at the time of creation. Mark the optional mark. If a mark has been set using the mark method, the toString output will include mark equals M. The mark allows you to return to a previously remembered position using the reset method. Format of the string asterisk. The string returned by bytebuffer.tostring will generally follow this pattern. If the mark is not set, it's omitted. Why it's not useful for data inspection. Crucially, the bytebuffer.tostring method does not provide a representation of the data contained in the buffer. It only tells you about the structural characteristics of the bytebuffer itself, its position, limit, and capacity. This is because bytebuffer can hold various types of data, bytes, integers, floats, characters, etc. The toString method doesn't know how you intend to interpret the raw bytes. Example asterisk. In this example, you'll notice that the toString output reflects the buffer's position, limit, and capacity, but it doesn't show the actual hello string. It tells us nothing about the data in the buffer. How to inspect the actual data in a bytebuffer. To see the data contained in a bytebuffer, you need to use the get methods or other methods to extract the data and then interpret it according to the data's type. Here are some common approaches. 1. Iterating and printing bytes asterisk. If you know the bytebuffer contains bytes that represent characters, you can read the bytes and cast them to char for printing. Important considerations. Encoding always consider character encoding. In the example above, we used standard charsets.utf_8 for encoding and decoding. If your data is in a different encoding, example ASCII, ISO 8859-1, UTF-16, use the appropriate charset. Flip, calling flip, is essential before reading from the buffer. It sets the limit to the current position, where the writing stopped, and the position to 0, so you can start reading from the beginning. 2. Reading specific data types, integers, floats, etc. If your bytebuffer contains integers, floats, or other primitive types, use the corresponding getType methods. Remember that the bytes need to be in the correct byte order, NDNS. Bytebuffer provides methods like order, byte order, to control NDNS. 3. Using char buffer and char set decoder for string conversion, more robust. A more reliable way to convert a byte buffer containing character data to a string is to use a char buffer and a char set decoder. This handles character encoding issues more gracefully. This approach is crucial when dealing with multi-byte character encodings, like UTF-8, to prevent character corruption. In summary, *bytebuffer.tostring gives you information about the internal state of the byte buffer object, position, limit, capacity, mark, not the data it contains. To inspect the data in a byte buffer, you must use get methods, example getInt, getFloat, getChar, to extract the data and interpret it according to its type and encoding. Remember to call flip before reading the buffer. Pay close attention to character encoding, example UTF-8, when the byte buffer contains character data, and use a char set decoder and char buffer for reliable string conversion. Consider byte order, NDNS, when dealing with multi-byte data types, integers, floats, etc. Use order, byte order, to set the desired byte order.